It is day 7 in Math Foundations, and for your do now today, we're just reviewing all the 4 operations: add, subtract, multiply, or divide. We're using integers here. There's 8 problems. We're going to start with number 1. Number 1, I have -4 minus -3.
-7.
I hear -1. I hear -7. -1, -7. Does somebody think they can raise their hand and tell me which answer is correct and explain why? Go ahead, Antoinette.
It's -7 because the 4 is bigger. There's all the signs is the same, and when it's a minus, you're supposed to add it.
Okay.
And it goes. So 4 plus 3 is -7.
So we have -4, and then you're changing that to a plus,
Yes.
and then we're changing this,
Yes.
okay, to also a plus. So now I'm going to rewrite the problem. -4 plus 3. So now that this is the problem, what's different?
The 4 is bigger, so you're supposed to add. You keep the first number the same.
Keep the first number the same. We are adding here. Now, when we add and we have the same signs, we just add like normal.
Yeah.
Are our signs still the same here?
No.
No. So what do we do different when our signs are not the same?
You change it. You change. Subtract.
Ooh, okay. So instead of adding, remember, if we go back to, I'm going to pull out my note page.
I was looking at because the first number was bigger. See,
Yeah.
That's why I get confused. That because I had -1 at first, and then I changed
Right.
it. I'm like, you're supposed to add. That's why I
Adding and subtracting integers. First, you would think it's the easiest part of math. It is the hardest. It is harder than algebra 2 and calculus and geometry. This is the hardest thing
I
you'll
get
do.
confused because I thought you were supposed to change the minus sign to
Yes.
addition sign.
So this is correct. We did our keep, change, or keep, add, change.
Mm-hmm.
But now we have like a whole new problem where we're adding and we have a negative and a positive. So we don't have same signs anymore. We have different signs, which means we're going to subtract the numbers, but keep the sign of the larger number. So keep the negative because 4 is bigger. But now what's 4 minus 3?
1.
1. So which answer is right?
-1.
-1. Good. That's tricky.
So yeah, it is really tricky because now I'm confused because do you only change it like if the first number is smaller than the second number?
Do you only change what?
So say for instance if it was reversed, if the 4 was inside the parentheses and the 3, is that when you not? I mean, is that when you keep it? That's why I'm
So
confused.
like if it was 3 minus -4.
Right.
So we change it when it's subtraction. It doesn't matter if the bigger number's first or the smaller number's first. Because what we're doing is we're changing. When we subtract, we're always rewriting the problem. We always do keep, change because it turns it into addition. So then we can just use the addition rules. Okay. So if I had 3 minus -4, I would do keep the 3, change to plus, change to positive. Now I have 3 plus 4, and that answer would be 7, +7. This answer is -1.
I got some more studying to do.
It's tricky.
It's really tricky because I feel like I had it one minute, then I feel like I don't get it. Then
Here,
I feel like
while
I do
we're
get
on
it.
the topic, while we're on the topic, let's do one very similar. Let's look at number 5. We'll skip around a little. Number 5, I have -4 minus -9.
Right.
So let's do that same keep, change, right? I'm gonna keep -4, change
We're gonna add that
to plus. Yep.
and then you keep the number because it's a bigger sign.
Okay. I think
You
I
see
see
why I
the
get
misunderstanding.
confused?
Yes. Okay. I want to address this. Whenever it says keep the sign of the larger number, I think that's a bad way to write it. I think a better way to say this would be subtract the numbers, but the larger number tells you the sign of your answer. Not keep it. No matter what, we're always gonna keep, change. We'll always change this. No matter what the number is. What I'm looking at now
I'm seeing it.
is -4 plus 9.
And it'd be -13.
And I see which number is bigger now, 4 or 9.
The 9.
The 9. And 9 is positive or negative?
Oh, negative.
Well, now it's
Positive.
now 9 is positive. Do you see that since we changed it?
It's crazy that I know how to do it when I'm doing it by myself.
Right. It can be very confusing, the subtraction especially. Thinking of it this way, like if I have -4 and then I add 9. If I'm starting with -4,
You take 9 and give you
Here.
13.
let's do this. I'm starting with -4, and then I'm gonna add 9. Add positive 9. I'll add 1, 2, 3, 4, 5, 6, 7, 8, 9. This is my answer. This is my answer. Positive 5
For the 5.
for number 5.
Oh,
So let's look at this again. We have. I'm gonna rewrite it. -4 minus -9. Let's follow our cheat sheet we did on day 5. Is this an addition problem or a subtraction problem on my student?
Subtraction.
That's subtraction. So under subtraction, it says the first thing we do is we rewrite the problem using keep, change. So let's start with that. So we keep what? Keep that -4.
Change. Subtract to add.
Change
Addition.
subtract to add. And then
Keep the -9.
now is it keep, change, keep?
No,
Keep change.
Keep, change. So what changes next?
So 9 turn into a positive.
Positive 9. So now I have -4 plus 9.
First answer was 13.
Now, here's what we did. Keep, change. The next thing says follow adding rules. Now we follow addition rules. We're ignoring the original problem. Now, do I have two numbers with same signs or different signs?
Different sign.
Different signs. So when I have different signs, we subtract the numbers. Keep the sign for your answer. So instead of keep the sign, because that's confusing, but keep,
So they
change.
give you -5.
The sign of the larger number is the answer. So -4, positive 9. Is 4 bigger or is 9 bigger?
9.
No.
9. 9 is positive or negative? Positive. So my answer is positive. And when I subtract 9 minus 4 or 4 minus 9, we get 5. Positive 5. Positive 5. Good. So if we ever subtract, we do keep, change, and then we use our addition rules. Okay. Any other questions about that number 5 here? Fractions are tricky.
Yeah.
Let's go ahead back up to the top. Let's number 2. Number 2, I have positive 2 times negative 4. Negative 8.
Now I'm gonna say that's -8 because it's always negative when there's a
Yes.
multiplication.
Yes, when you multiply, our signs are different. Our answer is negative.
It's I don't understand. I feel like I should have got the addition and subtraction. Where did I get the division and the
Right.
multiplication?
It's hard to
easier
try
with
to
that.
learn both at once.
Yeah.
It is. Number 3. +6 plus -8.
-2.
-2. Good. -2. This is adding with with different signs. So we find the difference, meaning we subtract. The bigger number is 8. 8 is negative. Our answer is negative. Okay. How about number 4?
-4.
I hear -4. Any other answers? +4. Okay, so this is a division problem. Do we have same signs or different signs?
Same
signs.
Same signs, even though they're negative. Same signs. When we have the same signs, is our answer positive or negative? Positive. So our answer is -4. It's not it. Yeah, +4. +4.
You didn't write that in the notes. See, that's where it got confused because you just put your answer is always negative for the notes.
Right here, different signs, your answer is always negative. Same signs, your answer is always positive.
Okay.
Yeah. Okay. Number 5 we already did. Let's look at number 6. What operation is this? Division. Same signs or different signs? Same signs. So will our answer be positive or negative? Positive. 20 divided by 4 is, I just heard it. Yeah, +5. Good. +5. Very nice. Okay, number 7. 12 minus 32.
Negative.
It's 20.
I hear negative, I hear positive. I heard positive 20. Was a negative 20 another answer? Okay. Let's see.
The 32 is bigger.
Yep. 32 is bigger. When we do the keep change, what does this become? Plus, and then positive 32 is now negative 32. When we add different signs, we're subtracting. So 20 is the right number. Is 12 bigger or 32 bigger?
Good morning. At this time, we are proceeding with our first filter drill of the year.
All right, we're back. Back from the storm drill. Last question. We have number 8. It says -9 minus 12.
I have
Oh, it's the
positive
same.
21.
Positive
I
21.
got negative, so.
Negative 21. Any other answers? So, what operation is this?
That is subtraction.
Subtraction. So, when we have subtraction, what does that guide say we should do?
Rewrite the problem.
Yes, rewrite the problem. So, keep change.
And then you add it.
Yeah, so keep the -9, make it addition, and positive 12 becomes
-12.
-12. So now what operation do we have?
We have addition with the same sign.
With same signs, that's right.
Isn't it? Okay.
That's right. So now it says add the numbers and keep the same sign. So what sign do we have?
We have
Negative. So our answer will be negative.
21.
-21. We got it.
Oh,
Good.
we did that.
Good. So here's what I think is gonna help. I'm gonna write, actually, let me pull up my notebook and I wanna give you the steps we just went through. Even though it might seem silly to write these out, I'm telling you, it really does help.
They really do though.
So in my notebook, I am gonna write day 7 notes.
So.
Anytime we are trying to, what do we want to call this? When using integer operations. Using integer. Okay. Step 1. First thing we always ask ourselves is, what operation is this? What operation is this? For example, is it, there's a plus addition, there's a minus subtraction. If we have the dot, that's our multiplication. And our division symbol, that's division. Okay. Based off of that first question, we then look at the steps. If it's addition, we look at the addition steps. If it's subtraction, we look at the subtraction steps. Those were from day 5. Once we figure out, okay, what operation is this? The second question we ask ourselves is, do my numbers have the same sign or different signs? See anybody? There you go. So do my numbers have the same or different? When we use these two questions, it can kind of help us a little more in deciding what to do when we solve the problem. So I'm going to have these two things written out, and let's see. I'm going to use an example from that do now. That first one, we struggled with it first a little bit. So I'm going to write that first problem out. -4 minus -3. So using those two steps, first, what operation is this?
Subtraction.
Good, subtraction. So step 1, what operation is this? Subtraction. And the subtraction rule is the keep, change. So now let's do that keep, change, where we keep -4, change to plus, change negative to positive. Step 1 is done. We used the operation rules, we identified its subtraction. But now, has our operation changed?
Yes.
It has. Now it's addition. So we follow addition rules. This is now where we ask ourselves the second question. Do my numbers have the same sign or different signs?
Different sign.
different signs. So, for that second step, step 2, we have different signs. And in our addition rules, when we have different signs, someone remind me, what do we do?
Wait, say what happened?
When we are using addition with different signs, what do we do?
Subtract.
Subtract. And my answer has the sign of which number? The bigger or the smaller?
The bigger.
Bigger. Subtract. Answer matches sign of bigger number. And of course, we talked about earlier, 4 is bigger, so negative is going to be our answer, -1. So sometimes just going through and making sure we're following these kind of questions that we ask ourselves when we look at a problem. You know, stop and think, what operation am I using? Don't just think, oh, I'm negative and negative makes positive, because that's only for multiplication and division. We want to make sure we're thinking about the right operation, following the rules, and then asking, now do I have same signs or different signs? What do I do based on that? So, that's just an example of a way to use that thought process to kind of move through solving some of these. What we're gonna do today, I mentioned earlier, we're gonna be talking about exponents. Exponents are not as scary as they sound. I think you guys actually might enjoy them a little bit because they're kind of interesting.
Exponents, but those are powers, right?
Yeah, the
So
powers.
That's when you just multiply it by the number at the top of it, whatever it is, that number.
You're halfway there. You're halfway there. I'll show you. I'm gonna flip my note page and right. Day 7 continued, and we're gonna title this exponents today. Exponent.
I'm thinking about the power, is that, what's it called? When you do it to like the highest, is that what it is?
Maybe.
It's been so long, I've been since 2009.
Crazy girl.
Long time.
You do a great job for being that long. H2. Okay.
What'd you say? What'd you say?
That film said 2009. I keep saying, yo,
I'm old.
No,
I'm
you
almost
ain't.
40, that's old.
Shit, you young.
You are not. Oh my
I'm 36.
Oh,
You
You
36?
look like, yes.
She
You
said,
look like
almost
you're
40.
younger than me.
That is only a few years from 40, that's old.
You got some
My
good
knees starting to
genes.
hurt.
Yeah, I remember.
When it rains.
You don't want it. You don't want it, baby.
I don't want it. Hey, you know what, I do want it because I learned a lot of people hated that. So actually I do.
That's right.
I'm patient, but I want it.
Yeah.
All right. Exponents. So up to this point, we've talked about 4 operations: addition, subtraction, multiplication, division. Exponents are really just like an extension of multiplication. When we have an exponent, here's what we're going to do. I'm going to write an example of a great big exponent using a marker here. I'm going to write 5, a big 5, and then a little 4 up at the top. Exponents are always smaller and they're never written on the same line. It's always above the number slightly. The way that we would read this is
5 times 4.
not 5 times 4,
Right.
5 to the fourth power.
That's what I was just asking.
Yes.
See, I knew
Yes.
it was something. See, that brain catching up.
Times 5, like 4 times.
Yes, exactly. So I'm gonna write here below 5 to the fourth power. That's how we say 5 to the fourth power. Our big number is our base number. So I'm gonna label this. So 5 is our base number. And the smaller number, or in this case 4, is the exponent or the power. So we have a base number and we have an exponent or power of 4. So exponent slash power. Okay. Exponents are repeated multiplication. So what this means is when I take a base number to a certain power, I'm multiplying the base number however many times the power tells me. So I'm going to do 5
Times 4.
times itself. 5.
So that's what I was wrong. I did it to
Yes.
the, okay, so that
Yes.
was the only look.
So 5 times 5, that's 2. Times 5, that's 3. Times 5, that's 4. This is 5 to the fourth power.
So that's 25.
So we could do it. 5 times 5 is 25. Now we can bring everything down. 25 times 5 times 5. What would I do next?
You were times 5 times 25.
Yep. 25 times 5. Let's see. Yeah, there's a really fast way to do this. I'll show you next. I like it. I'm gonna do that. So I know that's where it came from. Now we're doing 25 times 5. Thank you for showing me that.
No, like, because I could be, it's the,
Right.
I just did it so
That helps you keep track.
Because basically dropping it.
Right. So 25 times 5, I got 125. All right. Now I still have another times 5 left.
So you just keep passing it till the 5 is over with.
Yes,
basically.
you keep
just
going
keep on,
until
just
you're
keep
done.
going until it's basically just over with.
That's right. So what's 125 times 5? Gonna be a big number.
625.
625.
Yeah.
I just need to refresh you.
Yeah. So the answer, what is 5 to the fourth power?
625.
It's 625. So we'll write that out. 5 to the fourth power equals 625.
That's just as easy as the integers. I don't know how to say the word. The
Integers.
Integers.
Yes. Soft G. Integers.
It's almost.
Yeah. So let's do some examples of this. Actually, hang on. Before we do that, I'm going to write out to the side just so that we don't forget. Exponents are a form of multiplication. So I'm going to write repeated multiplication just as a side note. Repeated multiplication. And it's always multiplication. Below here, we're going to write out some examples. And after we practice a few of these, I'm going to show you a shortcut to how to find these answers. So
But I have a
fast.
question.
Yes.
Oh, you just use a down paper chart, can't you?
You could. Yes.
But
Okay, so you saying that the smaller number, how did y'all get 25
Get right five.
That's 5 times 5.
Yeah,
5 times 5 times.
So we started with the first two numbers being multiplied, 5 times 5, which is 25. So we were done with those. We brought down the other two fives. Now I have 25 times 5, which gives us 125. Then we have 1 times 5 left. 125 times 5, 625.
So you just basically just keep on multiplying it to the answer.
Yeah.
With the however many, with the power, however many powers it is.
So let's do some examples. Let's do number 1. 2 to the third power. What is my base number?
The base number is a 3.
3.
What is my base number?
2.
2. The base is the number touching the bottom.
Okay.
Base is the bottom. And then you can think about the power, the exponent, is above it and it's little. It's above it, it's overruling, it's got all the power. The base is on the bottom, the power is on top. Base is on the bottom. So 2 is my base number. The power tells 2 what to do. How many times will I multiply 2?
3 times.
3 times. So I'm going to write 2 times 2 times 2. There's 1, 2, 3 2's.
2 times 2 is 4.
Good.
4 times 2 is 6.
8.
8.
I'm sorry.
So that's exactly what we'll do. We start with the first 2. 2 times 2 is 4.
Oh.
2 times 2 is 4. I have one more times 2 left, and that gives me 8. 4 times 2 is 8. So 8 is 2 to the third power. Good. Let's do another one. Let's do 6 to the second power. 6 to the second power.
6 is the base.
Good. 6 is my base. 2 is the exponent or the power.
Right.
So what multiplication problem will I write?
6
6 times 6.
6 times 6.
6 times 6. I got 2.
That 2 is telling us we are going to multiply 6 twice.
36.
36. Good.
6 to the.
And that's it.
So it's 36 to the 6th power.
Just 36.
Oh, just 36.
36 is our answer. That's it. Let's do, here we go. Number 3, we'll try 10 to the fourth power. 10 to the fourth power. What multiplication problem can I write?
10 times 10 times 10 times 10 times 10.
Yes. And how many times?
4.
4. 10 times 10 times 10. One more times 10. That's 1, 2, 3, 4.
10 times 4 is 40. 40 times 10. I'm sorry. That's what I did.
So we have this all written out. What should I do first?
Times 10 to 10.
That's right. 10 times 10 is 100. I'll bring down the rest. I still have 2 more times 10s. Now I'll multiply 100 times 10, which is 1,000. I'll bring down, I have 1 more times 10.
Times 1,000.
10,000.
Times 1,000, what do I get? 10,000. So it's a 1 with 4 zeros.
I get that wrong.
Now there's a trick. Anytime you do exponents with 10, whatever the exponent is, the number, tells you how many zeros to write. So if it was like 10 to the 6th power, we'd have 6 zeros. If it was 10 to the 2nd power, we'd have 2 zeros. Kind of interesting. You don't have to know that, but it is a little fun fact. Let's do number 4. I will give you This one will seem like a trick. 5 to the first power.
That's just 5 times 5. No, 5 times 1.
5 times 5.
5 times 5 would be to the second power.
So it's
You're
just
seven.
5.
One time.
It's just 5. It's just gonna be 5. I'm asking myself, that number, that power tells me how many times to write the base number. So for 2 to the third power, we wrote 2 3 times. 6 to the second power, we wrote 6 2 times. 10 to the fourth, we wrote 10 4 times. 5 to the 1 or to the first power, we write 5 just 1 time. So the answer is just 5. Right. Yeah, that power says I only want one of you. I want 1 5. 1 5. And that's it. How about using that idea? What would 12 to the first power be?
12.
12. If the power is 1, then the answer is just your number. Let's see. Here's a tricky one. What if I have -4 to the second power?
That would be,
What multiplication do I write?
you would be -4
Mm-hmm.
times 2. Times 2. Times 2.
Not times 2.
I mean, you'll write -4 2 times.
Yes, right. -4 2 times. We're doing -4
Which will give you -6.
times -4.
I
Now,
mean, -30.
now let's think. This is multiplication, right?
4.
When I have the same signs in multiplication, will my answer be positive or negative?
It's gonna be positive.
Positive.
So it's positive 16.
Positive 16. Good. Good. Because a negative times a negative is a positive. Yeah. Positive 16. You guys can also always double check your answers on your calculators. I'll never be upset with you for doing that. You can always check that. -4 times -4. That's positive 16. The negative button is down here at the bottom. Right. Yeah, it's always smart to have your notes written down. You can go back and check all the rules.
Everybody hospital too was really good.
I'm not good for hard. I like
You the
it.
mom.
Right. You got my house. See, my kids don't bring you out.
Right.
That's why I like
I like
it.
it.
It always applies.
Right. Always. Okay, I'm gonna give you guys a few to try on your own. And we'll see how you do. Let's see. I'm gonna flip this page. Depends how I'm feeling that day and like what's going on. So you're giving you anxiety. Like that. Day. You try. So I'm gonna give you. First one will be 8 to the second power.
You doing this out loud?
You guys are going to try these on your own, on your paper. We'll go through the answers in a few minutes here. But I want you guys to try them on your own first. Then I have 9 to the fourth power. Then I have -4 to the third power. And I have 5 second power. One more. Here's the challenge one. The second power plus 3. The third power.
Ooh, you turned your brains to bag.
Try those. I'll give you guys a few minutes. And we'll review together.
This is what I'm hoping to do. I'm like. You get
When
what
you
you do.
multiply those two, because those two numbers at the end, when you add them together, that's gonna give you the right answer. You're like one step away.
That's what I'm saying, there's something that's connected.
The only thing that's, how did you get your final answer there?
Okay.
Did you
So-
multiply those two numbers?
Believe me, that's the hard problem.
I bet that's what you did, so try adding them, that's what you're right.
That's what I'm saying, something's not right.
Type it in again, because that's right, that's right.
Something's not right. Or maybe we are running it wrong.
Maybe.
You see what I'm saying?
I see what you're saying. Okay, guys, let's look at number 1. 8 to the second power. What am I doing here?
Yeah.
8
8 times 8.
8 times 8, which is 64.
I'm looking at
Good.
I'm looking down the cover right there.
Right, here, we'll focus one at a time. For some reason, there's random problems that I will always remember because of silly little tricks I learned in school. For 8,
I'm glad.
I remember, I always have 8 times 8 memorized because there was a little rhyme I learned in school. They said, 8 and 8 went to the store. They bought a Nintendo 64. So I just always remember that. 8 and 8 went to the store, got a Nintendo 64. Let's look at number 2. 9 to the 4th power. Yes, 9 times 9 times 9 times 9, and that.
9 times 9 is 81.
Yep, 9 times 9 is 81.
81 times 9.
And
81 times 9.
is
729
729
times 9.
times 9.
6, 6, 5, 6, 1.
Woo! 6561.
That's the answer I get.
6,561. Good. Okay. Number 3.
4
Negative 4 times negative 4 times negative 4.
Yeah, negative 4 times negative 4 times negative 4. So first, negative 4 times negative 4 is
Positive 16.
positive 16
times 4.
And then
times negative 4.
64.
64, positive or negative?
Positive.
Positive times a negative, different signs give us a
Negative.
negative answer. Good. Negative 64. Good. Number 4.
5 times 9. Negative 5
That's
times
right.
negative 5.
Negative 5 times negative 5 is
25.
Positive 25.
positive 25. And last but not least, this final problem. We got to be careful. Use our order of operations.
What?
We're going to do the exponents first. Do not add until we have the answer to 4 to the second power and the answer to 3 to the third power. So let's do 4 to the second power first. How do I do that?
4 times
You would do 4 times 4,
4 times 4,
which will give you
16. Good. So I have 16. Instead of 4 to the second power, I'm going to write 16.
and then you would do 3 times 3 times 3.
Yes. 3 times 3 times 3.
3 times 3 is 9.
9.
9 times 3, 21.
Almost.
27.
27.
So you got 16 plus 27.
Yes. Yes. 16 plus 27
And that's your answer.
is
43.
43? Is that what it is?
No.
Yeah.
Say
What? 27.
that's 43.
43. Good job, you guys. Good job.
Can I copy those real quick?
Yes, yes. I will leave this up on the board. First, I'm going to show the exit ticket on the board for people at home. But I have passed this out to all of you. It is 10:18, so there is a little over 5 minutes until the bell rings. If you do not finish, no big deal. We've got, tomorrow to finish if you have not yet today. But real quick, your day 7 exit ticket is 6 exponent problems. That's it.
Do we turn those in or do we bring them back?
You can turn them in if you finish. If you don't finish before you go, you'll just bring it back and then turn it in tomorrow or whenever. Yeah. Yeah.